Hi, David Johnson again, CEO of Gingerbread Homes. Um, this last section on the GB Education, session 5, is on profitability. And again, I would refer you to the investor invitation document that goes a whole lot more in detail on the pro forma of this operation and how there's a lot of profitability in this approach. First thing I'd like to pass along to you is how vital it is that we go and take a look at what's happening now with the construction industry. There's been many studies done, and in the past 2 or 3 years, the uptick in interest levels as far as technology in the construction industry has absolutely gone out the roof. And so there's a lot of companies that are trying a lot of different things. They're trying a lot of different approaches. They're trying to go at it in a lot of different ways. And that's good. That's a sign that, hey, there's some activity here. And we got 3D printing out there, that we're trying to print houses with a 3D printer. And so those are all good things. This approach is it's unique in and of itself. The novel idea of robots working together on-site and off-site kind of converges into a huge possibility. But for the investor to take a look at this and say, okay, does it make sense? What is the return on investment? And how does all that look? It looks actually very good. I will tell you this, if, let's just say, for this example here, let's say there's 12,000 cottages built. The overall net profit on that is about $500 million, with multiple revenue streams added to that. And so you can see there's really great potential as far as being able to make a go of this and make it profitable. And the nice part about it is they're never going to go away. Everyone's always going to need a house, cottage to live in. So it's not like it's just here now and gone tomorrow, but they'll always be there. There have been companies that have gone and really hit it hard as far as offsite building components for the industry, but they could never get the sales because, you know, it just wasn't scalable, or it wasn't an integrated business. What I'm talking about in GB is an integrated business. So let me try to diagram this for you a little bit. So let's say we have the product here, okay? And the product is going to require windows. So an integrated process would say, well, okay, are you going to rely on a third party to provide you with the windows? In our scenario, we're saying no. We want to go ahead and we're going to build that. So that's going to be an integrated business, a part of the GB platform, the product itself. Same thing with doors. So we do the same thing with doors. We say, okay, that's also going to be integrated and be done by GB. And by the way, when you go off and you do these subcomponents that go into the final product, these are areas where robotics also apply. So then the efficiencies are there. And then revenue streams can come from these side businesses to sell doors or windows or whatever to other companies who may be looking for those. So you're supplying your own, but then you're also creating a revenue stream from others who want to also buy those subcomponents. So that's just to give you a little bit of a taste of where you can go with this, because it's a big widget. It requires a lot of things to go into it, but it's very simple too, because it's basically, it's like robotics building little transistors or little chips. There's a lot of pieces on them, and they're just really micro, small, and everything. This is just a lot of pieces, but it's just bigger. And so it's basically the same process. So what I did, working on my MBA in artificial intelligence, a dissertation that I wrote, went through this whole process of asking the questions about, is it feasible? And so I interviewed experts in the field from both sides, from the construction industry and also from the robotics industry and AI, and got their feedback and started to piece together what was actually, or what could happen. And the key would be the R&D part of it. So according to the experts, they're saying, yeah, this is great. This is on the robotics side. They said, well, we're not sure exactly how you build a house or anything like that, but we know this is what robots can do, and let me tell you what robots can do. So they went through their justification for building construction robots. On the same side, the construction side, they said, yeah, sheesh. I mean, the argument for a robot is huge when you can say, well, gee, so 4 robots, or 6 robots, 2 sitting idle, and while they're being charged, and the other 4 working continuously, would actually displace 80 workers. Wow. And so your investment is a one-time investment, and it pays itself back in a month. Wow. I mean, that's the kind of opportunity we're talking about here. And so if you also consider the fact that part of this whole argument is it becomes a decision tree analysis. And so what I did is I just said, okay, fine. So I'm asking all these experts these questions, and there was an if statement that said, okay, if they answer this to this, what will be the outcome over here? And interestingly enough, the study brought out the fact that, well, all these questions that were asked of these experts, they went ahead and said, well, yeah, that definitely makes sense. It makes all the sense in the world. Why haven't we already been doing that? And that's a great question. I don't know why we haven't, but we should. And so there was basically 4 major points that came out of this study. One of the first one was AI simulation. And the consensus was, if you could actually go and simulate everything ahead of time, what are the chances of making errors? What part of the construction industry does that today? Nobody does, because it's not a fully integrated product. You might have a manufacturer over here that's making walls and selling them to, build apartment buildings or build office buildings or whatnot, but that's just one small part of the whole project. There's all these subcontractors and everyone else that's involved in it, so it's still a project-based system, and you can't simulate that because it's going everywhere. What you can simulate is the things that happen repetitively over and over and over again. So the marrying of the two items, the robotics and the product together as one, is the next point. So this was number 1. They just love the fact that you could AI simulate the whole process. You can see what the robots are going to do ahead of time before they ever do it. You can see what the cottage was going to look like in its raw form in 3D CAD on the computer, and you can also go and say, well, at the end of the day, based on our AI analysis of how it went on this particular site, we found out XYZ, and we now know we can improve this on the next go around so that it gets better. So the quality goes out the roof, and it just gets better and better. It gets more and more consistent, and pretty soon people are walking around, I live in a robotic house. Ooh, it was built by a robot. Ooh, and they're thinking, well, I'm not saying that's necessarily a sales point, but it actually goes and lends something to what we're all about as far as the product goes. So the next thing being the product and the CR, as in the construction robot, they have to be one as to, in order to make the whole thing work. So that was another thing that came out of the study. The experts said, yeah, we understand that, it makes sense, that's the best way to go with it, as far as we can tell, And then other points were, well, the product is manufactured. So just like you buy a car, say you buy an Elon Musk Tesla and you want to keep it. Well, of course, you buy it, so you can't keep it. It doesn't matter where you live. You take your Tesla wherever you go. What do we do with houses? Oh, well, it's part of the real estate. I got to leave it because I'm moving to another place. In this case, you can unbolt it, put it in shipping containers, take it to the new site. You still have your investment. Not a bad idea. And so those kinds of things are possible when we're talking about a manufactured product. So that's number 3. Manufactured product is higher quality. It leaves you with less options as far as a customer goes, and essentially takes away the customization of whatever when a builder is building something and they make a change on the fly on the blueprints and they're going to add this in and add that there. You got a custom house going up every day almost when they're building these things, or you got these developers that are putting up these different ones based on some floor plan, and so they're all over the map as far as consistency goes. What this does is it says, okay, we're going to make this consistent no matter where we're at, no matter what we're doing, and therefore we can ship the product anywhere in the world, anytime. So it opens itself up to becoming a customer-concentric product. It's all based on what the customer wants, or at least the majority of the population. Recognize we're not going to be able to meet all the demands all the time, and if somebody wants a custom built house and they go hire an architect and they do whatever else they have to do to get it, that's fine. But as far as what we're trying to provide here, from an affordable housing to the modest homeowner that just wants to get into something they can afford, especially with everything the way it is these days, the supply chain and everything else that goes with it, that's a tough situation to be in. So after all of this analysis was done, the conclusion was, this is something that definitely should be investigated, it should be looked into, and it should be tried. So here's the basics. Just for startup costs, I'm estimating it's going to cost about $22 million. That $22 million includes a manufacturing facility, a lab, and produces 4 show homes, 4 cottages, and also takes care of all the hardware and the software for 6 robots. So those robots become the prototype for the future ones, and they become usable in putting together cottages as soon as they're built, so they can begin making profit. And so also it includes, that dollar figure includes ISO certification, ISO 9001 certification, so that from a manufacturing standpoint, you've got credibility that's recognized around the world. And so put together, all those things put together, and then as far as the cash flow over a period of 3, 5, and 10 years, those projections add up, and the details of that you can find in the investment invitation, and it'll give you a little bit more granular knowledge there as far as the dollars and how profitable it is. So I think that from the construction industry standpoint, that this is something that is, it's been long overdue. It's been something that's been needed for an awfully long time. And one of the quotes I had to chuckle at, the individual said, well, you know what, I got a journeyman carpenter that's charging me $95 an hour and giving me lip in the process, and then he screws up the job anyway. And he says, I'm tired of that. The human capital side of construction is our biggest problem. If we can introduce robots to the point where the goal here is that the product is 95% built by robots, up to 95%. And then the rest, there might have to be some human intervention there. But I'm talking all the way from the off-site to the on-site, and even on-site where the hole is dug by robots, foundation is laid by robots, and as much of the landscape that can be done is done by robots, contouring and everything, all that's done by autonomous vehicles. And at the end of the day, you've just gone ahead and you've saved huge amounts of costs. Capital investment's high because you have to buy the machines, the tools. It's not just a hammer and a tape measure, but it's actually now a machine that has to be invested in that makes this product, and that requires some R&D, and that requires some capital investment. So I hope you'll take a look at it. I hope you'll take a serious interest in it, and that you'll find that this is definitely a way to approach the construction of cottages for the future. Thank you.